So in the previous few sessions, we have already talked about definition and value of a function, as well as basic things about domain, range, etc. In this one, we are going to talk to you about algebra of functions. Now, you people, when you actually started with integers or rational numbers, you already saw how to add them or subtract them, etc. Now that you have some knowledge about functions, we'll see some operations of functions. So let's get started. So the first one that we are going to do is, the first thing, we are taking two functions here. The first one is f, which is from d1 to r. D is actually the domain corresponding to this first function, and g is d2 to r, where d2 is its domain. So addition, so how do you add two functions? So if you add two functions, they will be actually from the common domain to r. So f plus g of x is defined as fx plus gx. So you find out the values individually and you add them. Similarly, for subtraction, you can actually have the subtraction of two functions. It is defined as f minus g of x as fx minus gx. Again, look at the common domain, because whatever we do, don't forget that it's actually about functions. So whatever basic things you have learned so far, don't forget about them. The third thing that we are going to learn is multiplication by a scalar. So suppose you are taking any scalar, which is actually any real input, and if you just multiply it with a function, then it will be nothing but the multiplier into the value of the function. Product, same thing. If you just look at the pattern, if you take f into g, that is the function, the product of two functions, the output will be the product of the individual components. Similarly, we can have quotient. Now this part is very, very crucial. After this one, where we have taken the quotient of the respective values, let's look at this one that we have taken. If you look at gx, which is in the denominator, we have to understand that this has to be non-zero, because at the end of the day, we are talking about functions, so the image has to be defined. So that is why from the common domain, we have got rid of all possible x's for which gx will be 0. Now that we know what are the basic definitions and operations, let's see some examples. So basically you have two functions here, fx equals to e to the power x and gx equals to log x. We have to find f plus g of 1. So what is the basic definition for addition? It will be f1 plus g1. So find out f1 by putting x equals to 1 in f, which is e to the power 1. Similarly, g1 is log 1. Now just do the basic calculations. You'll see that the output will be E. So that is how you can define them. F into G of 1. So you take the corresponding values and you multiply them. So we have already found out the values from the previous example. So it's going to be E into 0, which is 0. Third example is 3f of 1. So what is 3f? It's nothing but the scalar multiplier. So this 3 can come outside and we have to take the value of f1. So put x equals to 1 in fx, and this is what you're going to get. Alright, so I hope you understand how we can actually perform operations on functions. And for a specific input, we can find out the output. Now, apart from these kind of applications, sometimes we also find out some general functions. So you have fx and gx. You have to find out f minus g of x. So I'm not finding out the specific value for a specific input. I'm just finding out the function in general. So what is the definition? That is fx minus gx. So this is fx minus gx. So this is how it's going to look like. So if you know the original function and original values, then you subtract, or you simply use this function, it's going to generate the same output. Similarly, if you look at the quotient here, same, just find out the individual components and take the quotient. Now be very careful when it comes to quotients, because if you look at the denominator, it's not going to be defined if you put x equals to 3 or x equals to minus 1. So you can consider any real values apart from these two. So whenever you're considering the operations, I hope you understand how we can use the definition, but be very cautious about domain and the corresponding things that we don't have to consider, especially for quotient. On many occasions, what we do is we simply use these algebra of functions without even realizing their importance, but just because we have these definitions, so we can use them. So I hope you understand. the entire concept. In the next few videos, I'm going to talk to you about various standard functions, so stay tuned.